We like to imagine that the map of our world is a finished masterpiece, a static stage where the drama of human history unfolds in a permanent setting. But beneath the rhythmic pulse of the tides and the silent weight of the abyss, our planet is hiding the shattered remains of its own violent past. On a dark September night in 1931, a small British fishing boat named the Kalinda was dredging the North Sea, 40 kilometers away from the nearest shore. Among the flopping fish and tangled seaweed, the crew pulled up a heavy, dark lump of peat that seemed entirely out of place in the salty brine. Embedded deep within that ancient mud was a 20-centimeter harpoon head, meticulously carved from the antler of a red deer by a hand long since gone. This single jagged artifact whispered a haunting truth. Where cold waves now crash and tankers sail, humans once walked, hunted, and called the Earth home. This was Doggerland, a sprawling prehistoric plain that connected Great Britain to mainland Europe, a lost world swallowed by the relentless rise of the melting glaciers. Since that discovery, the ocean floor has yielded more secrets, from the massive tusks of woolly mammoths to the silent, predatory skulls of ancient European lions. These are not just random relics, they are the debris of a vanished geography, proof that the boundaries of our continents are far more fragile than we realize. We often think of the ground beneath our feet as the ultimate symbol of permanence, but in geological time, the land is as fluid as the water. While the myth of Atlantis captures our imagination with stories of a sunken city, the reality revealed by modern science is far more vast and humbling. Using advanced gravity mapping and deep-sea sonar, researchers are discovering that entire continents have been ripped apart, crushed into fragments, or dragged into the mantle. Imagine a landmass twice the size of India, a hidden giant stretching across the South Pacific, with 94% of its body submerged beneath the waves. This is Zealandia, a true geological continent that remained hidden from our maps for centuries, even as explorers sailed directly over its silent, sunken peaks. In 1642, Abel Tasman searched for a great southern continent to balance the world, but he only saw the jagged mountains of New Zealand's South Island. He never realized he was standing on the highest tips of a drowned world, a massive tectonic plate that had been thinning and sinking for millions of years. It took 375 years of scientific progress to finally recognize Zealandia as a distinct continent, separate from the neighbor we call Australia. To qualify as a continent, a landmass must have a thick crust, a wide variety of rocks, and a clear elevation above the surrounding oceanic floor. While the oceanic crust is typically less than 10 kilometers thick, the continental crust of Zealandia is a robust slab reaching depths of nearly 40 kilometers. The discovery of these lost lands forces us to ask how much of our planet's story is currently written in a language we cannot yet see or hear. To understand why continents sink, we must view the Earth not as a solid rock, but as a restless, churning machine of heat and pressure. The tectonic plates that carry our civilizations are like massive rafts of granite floating on a semi-liquid sea of much denser, hotter magma. As these plates drift, they are caught in a perpetual tug of war, being pulled apart to birth new oceans or crushed together to forge mountains. We perceive the Alps or the Himalayas as eternal giants, but on a planetary scale, the surface of the Earth is almost perfectly smooth. If you shrunk the Earth to the size of a soccer ball, our highest peaks would be no larger than a tiny grain of sand. The vast oceans that define our blue planet would be thinner than a single, delicate layer of plastic wrap stretched across that ball. From this perspective, it is easy to see how a slight shift in gravity or temperature can cause entire regions of land to submerge. During the last Great Warming period 18,000 years ago, the melting ice caps released enough water to raise sea levels by 120 meters. This global flood didn't just happen overnight. It was a slow, agonizing crawl that gradually turned valleys into bays and hills into islands. But there is another force at play, a rhythmic breathing of the Earth's crust known as glacial isostatic adjustment, or the seesaw effect. When massive ice sheets weigh down a continent, they press the crust deep into the mantle like a finger pushing into a soft sponge. As the ice melts, the land begins to bounce back, rising slowly out of the sea, while other nearby areas are forced downward in response. This is why Scotland is currently rising out of the waves, while the city of London is slowly, inevitably, sinking into the mud of history. In Scandinavia, the land is rising so fast that coastal towns have had to move their harbors twice to keep up with the retreating sea. Even the weight of modern cities can contribute to this descent. New York City is gradually sinking under the sheer mass of its own skyscrapers. However, the most dramatic disappearances occur when a continent doesn't just sink, but is actively consumed by the belly of the Earth. Beneath the beautiful landscapes of southern Europe lies the ghost of Greater Adria, a continent once the size of Greenland that vanished completely. For millions of years, Greater Adria was a tropical paradise of shallow reefs and volcanic islands, caught between the giants of Africa and Europe. As Africa began its slow, unstoppable journey northward, it acted like a colossal vice, squeezing Greater Adria until the smaller landmass began to shatter. Unable to withstand the pressure, the continent was forced downward in a process called subduction, sliding into the darkness of the Earth's mantle. Today, the only remnants of Greater Adria are the limestone peaks of the Alps and the Apennines, rocks that were literally scraped off as the continent dove. This geological pileup is far from over. Africa continues its relentless march north, threatening to one day erase the Mediterranean Sea from our maps. If this collision continues, the familiar coastlines of Italy, Greece, and Turkey could be crushed into the rising peaks of a future mountain superrange. While some continents are consumed by fire and pressure, others are lost through the subtle, invisible variations of the Earth's own gravitational field. Around the island of Mauritius in the Indian Ocean, scientists noticed something strange. The pull of gravity was unexpectedly, exceptionally strong. This gravitational anomaly suggested a hidden mass beneath the seafloor, a secret that the volcanic rocks of the island were finally ready to reveal. Inside these rocks, geologists found ancient crystals called zircons, tiny time capsules that are far older than the 8-million-year-old island itself. These zircons are billions of years old, suggesting that Mauritius is sitting directly on top of a fragmented ancient continental crust. This lost land, now called Mauritia, was once a bridge that allowed prehistoric life to walk between the landmasses of Madagascar and India. But as the supercontinent Gondwana shattered, Mauritia was stretched thin and dragged down, leaving only microscopic crystals as witnesses to its existence. 10,000 kilometers away, on the edge of the Arctic Circle, another mystery challenges everything we thought we knew about the North Atlantic. For decades, we believed Iceland was merely a young volcanic formation, but its crust is 40 kilometers thick, the signature of a veteran continent. Professor Gillian Folger and her team now propose that Iceland sits upon Icelandia, a sunken continental plate stretching from Greenland all the way to Europe. If Icelandia exists, it would rewrite the history of how the supercontinent Pangaea broke apart, turning a simple volcanic story into a continental epic. But the discovery of Icelandia isn't just a matter of scientific curiosity. It has ignited a fierce political debate in the corridors of power. Under United Nations law, proving that the seabed is an extension of a nation's continental crust grants that nation exclusive rights to its resources. Continental crust is a treasure trove of minerals and hydrocarbons, the remnants of ancient forests and swamps that never existed on the deep ocean floor. This creates a dangerous paradox. Our search for knowledge about the Earth's past could inadvertently trigger a race to exploit its most fragile depths. If the seafloor becomes a political battleground, we risk destroying ancient ecosystems before we even have the chance to understand their complexity. We are entering a new era of discovery, where the final frontier isn't just in the stars above, but in the dark, silent plains beneath our feet. The exploration of these vanished realms is no longer a matter of guesswork. We are using the very pulse of the Earth to see through the abyss. In Antarctica, researchers at Durham University are deploying ground-penetrating radar to strip away kilometers of ice and reveal the hidden world beneath. What they have found is a landscape of ghosts winding river valleys and jagged mountain peaks that haven't seen the sun in 30 million years. This frozen continent was once a lush haven of temperate forests, similar to the vibrant green wilderness of modern-day Patagonia or New Zealand. The transformation from a green paradise to a white wasteland was driven by the slow, grinding movement of the continents away from each other. When South America and Australia drifted north, they opened a deep-sea gateway that allowed the Antarctic circumpolar current to begin its endless cycle. This massive conveyor belt of freezing water acts like a thermal barrier, trapping the cold around the South Pole and starving it of equatorial warmth. Today, 90% of the world's ice and 60% of its fresh water is locked in a vault that is, in places, 5 kilometers thick. If all that ice were to melt, the land beneath would rise as the crushing weight is lifted, but the rising seas would rewrite every coastline on Earth. The story of these lost continents teaches us that our climate is not just a product of the atmosphere, but a result of geographic destiny. If Doggerland had stayed above the waves, the warming currents of the Atlantic might never have reached Europe, plunging the continent into permanent winter. Our ancestors who hunted across the North Sea plains were witnesses to the end of a world, as the solid Earth literally dissolved beneath their feet. We often view history through the lens of human conflict, but the true master of our fate is the slow, inexorable drift of the tectonic plates. The minerals we crave for our future technology are the buried treasures of these sunken lands, forged in fires that burned millions of years ago. Deep ocean mining is currently a restricted frontier, but the pressure to fuel our modern lives is mounting against the walls of international law. We face a profound choice. Do we treat the ocean floor as a resource to be plundered, or as a laboratory for understanding our planet's survival? Every zircon crystal found in Mauritius and every mammoth tusk pulled from the North Sea is a reminder of how much we have yet to discover. We know more about the craters on the Moon and the dust on Mars than we do about the vast plains of Zealandia or Icelandia. Our journey into the deep is not just a search for rocks and oil. It is a search for our own origin story as inhabitants of a changing world. As we look toward the horizon, we must remember that the ground we stand on is merely a temporary visitor in the grand cycle of geological time. To truly grasp the scale of these lost worlds, we must travel back 300 million years to the era of the supercontinent Pangaea. Pangaea was the ultimate jigsaw puzzle, a single massive landmass surrounded by the global ocean of Panthalassa, containing the seeds of every future nation. But the same internal heat that forged this union also sowed the seeds of its destruction, as thermal currents began to rip the Earth apart. Pangaea split into two northern and southern giants, Laurasia and Gondwana, separated by the Tethys Ocean, a waterway that ran from east to west. As Gondwana drifted toward the South Pole, it began to fragment into the familiar shapes of South America, Africa, Antarctica, India, and Australia. However, hidden within this divorce were smaller microcontinents, fragments of crust like Mauritius and Zealandia that were doomed to be left behind. The story of Greater Adria is perhaps the most tragic. It was a Greenland-sized tectonic traveler that got trapped in a continental collision. As Africa pushed north, it didn't just meet Europe, it literally climbed over Greater Adria, shoving the smaller continent deep into the furnace below. Today, geologists at Utrecht University use seismic tomography, a kind of planetary CT scan, to track these sunken slabs as they descend into the mantle. They can see the cold, rigid remains of Greater Adria resting 1,500 kilometers beneath the surface, a stony corpse in a tomb of fire. This process of subduction is the Earth's way of recycling itself, turning the old, heavy crust back into the molten fuel of the future. But not everything is recycled. Sometimes, the Earth holds on to its secrets, keeping them preserved in the dark, high-pressure silence of the deep. In the Indian Ocean, the discovery of Mauritius was only possible because volcanic eruptions acted as natural elevators, bringing ancient rocks to the surface. These eruptions were not just disasters, they were messages from a world that disappeared when the dinosaurs were still reigning over the land. Similarly, the mystery of Icelandia challenges our understanding of the Atlantic's birth, suggesting that the breakup of Pangaea was far more messy than expected. Instead of a clean snap, the continents may have stretched and thinned like warm plastic, leaving behind vast, sunken bridges of continental rock. If Icelandia is real, it means that the seafloor in the North Atlantic is actually a submerged mountain range of ancient, mineral-rich granite. The existence of these lands fundamentally changes our perspective on international waters and who truly owns the riches of the Earth's crust. We are forced to decide if these sunken continents belong to the nations that sit above them or if they are the heritage of all humanity. As we stand on the threshold of this new exploration, we must ask, are we ready to face the ghosts of the world we used to be? As we peel back the layers of the deep, we find that the ocean floor is not a barren desert, but a graveyard of lost geographies. Every discovery, from the peat of Doggerland to the granite of Zealandia, acts as a reminder that the maps in our textbooks are merely snapshots. In the North Sea, the Calinda's harpoon head was only the beginning. Since then, thousands of artifacts have been recovered by industrial dredging operations. These objects tell a story of a resilient people who lived in a land of plenty, unaware that the sea was rising to claim their world. This wasn't a sudden cataclysm like a Hollywood movie, but a slow, generational retreat as the horizon moved closer every single year. Imagine the final generations of Doggerland, watching their hunting grounds turn into salt marshes and their ancestral forests into shallow lagoons. This process, driven by the end of the last ice age, is a mirror to the climate challenges we face in our own modern era. But while Doggerland was drowned by rising water, the continent of Zealandia was betrayed by the very crust it was built upon. 85 million years ago, Zealandia was a proud part of Gondwana, but as it broke away, the crust began to stretch and thin. Like a piece of dough being pulled too far, the continent lost its buoyancy and began to sag into the dense mantle below. Today, we see only the mountaintops, the islands of New Zealand and New Caledonia poking out like the tips of a giant's fingers. The rest of this massive landmass lies a kilometer deep, a silent kingdom of underwater plains and dormant volcanoes larger than the European Union. Mapping such a vast area is a monumental task, requiring fleets of specialized ships equipped with multi-beam echo sounders to paint the seafloor. These maps reveal a complex topography of ridges and basins that challenge our traditional understanding of how continents behave when they die. Unlike Greater Adria, which was violently crushed, Zealandia simply gave up its place in the sun, slowly surrendering to the crushing weight of the Pacific. This quiet disappearance makes it one of the most difficult continents to study, as its secrets are spread across millions of square kilometers. Yet, the rocks we do manage to retrieve from Zealandia's depths are remarkably similar to the ones we find in the heart of Australia. They contain the same minerals and the same ancient fossil records, proving that these two neighbors were once inseparable parts of a single family. The discovery of Zealandia isn't just a win for geology, it is a profound lesson in how much of our world remains invisible to the naked eye. It reminds us that we are walking on the literal edge of a vast, submerged reality that we have only just begun to chart. If we move across the planet to the Indian Ocean, we find a different kind of tragedy. A continent not just drowned, but torn apart by giants. Mauritius was once a sturdy land bridge, a geological ribbon that allowed the ancestors of lemurs and dinosaurs to traverse between Madagascar and India. As the foundations of the Earth shifted, the plate beneath Mauritius was stretched by the immense pull of India migrating toward the Eurasian collision. The continent didn't sink as a single piece, it shattered like a glass bridge, with its fragments scattered across the deep floor of the Indian Ocean. For millions of years, these fragments remained hidden, until the gravity-defying strength of the Mauritius anomaly forced us to look deeper into the abyss. Scientists were puzzled why a small volcanic island possessed such a heavy gravitational footprint, as if it were hiding a secret mountain beneath. By analyzing the lead and uranium isotopes within the zircons found there, they calculated an age that predates the surrounding ocean by billions of years. This revealed that the island we see today is merely a young volcanic skin draped over the ancient, weary bones of a lost continental world. This phenomenon of ghost continents suggests that the bottom of our oceans might be littered with the remnants of many other failed landmasses. While the Indian Ocean hides shards of glass, the North Atlantic hides a massive, heavy secret that could redefine our understanding of volcanic islands. Icelandia, if proven, would be a sprawling plateau of continental crust that never truly broke away when North America and Europe parted ways. This theory, led by Gillian Falger, suggests that the breakup of the Atlantic was less like a clean snap and more like a messy stretch. Beneath the hot springs and basalt of Iceland lies a foundation of granite so thick it defies every standard model of oceanic crust formation. But this scientific revelation has stepped out of the laboratory and straight into the volatile world of international maritime law and resource rights. The United Nations Convention on the Law of the Sea dictates that a nation's territory can extend as far as its continental shelf allows. If Icelandia is recognized, it would grant tiny Iceland control over an underwater territory nearly as large as the entire European landmass. Inside this sunken territory lie the ingredients of our modern future: rare earth minerals, massive oil reserves, and deep-sea hydrothermal vents. This creates a friction between our desire to protect the common heritage of mankind and the nationalistic urge to secure energy independence. We are quickly approaching a crossroads where the maps of the past will dictate the wars and economic booms of the coming century. The quiet, dark plains of the seafloor are suddenly glowing with the light of human greed as we prepare to drill into history itself. While the political world argues over ownership, the most isolated and mysterious lost continent remains locked in a vault of solid ice. Antarctica is a massive landmass, larger than Australia. Yet we know more about the craters of Mars than we do about its hidden valleys. Only recently have researchers used satellite imagery and ground-penetrating radar to strip away the frozen layers and map the ghost world beneath. They discovered a terrain sculpted by ancient rivers and jagged mountain ranges, preserved in a state of suspended animation for 30 million years. The coastline of this hidden continent is a moving target, pushed deep into the Earth's mantle by the crushing weight of the ice sheet. This ice, nearly 5 kilometers thick in some regions, holds 60% of our planet's freshwater, a sleeping giant of climate equilibrium. By analyzing magnetic data trapped in ancient volcanic rocks, geologists have reconstructed Antarctica's epic journey across the face of the Earth. Long before it was a frozen desert, Antarctica was a lush, temperate paradise located much further north, teeming with life and ancient forests. Fossilized plant records from Alexander Island reveal a world of giant ferns and conifers, remarkably similar to the temperate rainforests of modern Patagonia. The tragic cooling of this continent was not caused by a lack of sunlight, but by its own geographical isolation over the South Pole. When the gateways of the Drake Passage and the Tasmanian Gateway opened, they unleashed the powerful Antarctic circumpolar current. This endless loop of freezing water acted like a thermal wall, blocking the warmth of the equator and imprisoning the continent in frost. If the position of these continents had shifted only slightly, the entire global climate would have taken a radically different path. This realization reveals that the stability of our modern world is a fragile accident of where the tectonic plates happen to stop. If the lost continent of Doggerland had remained dry, the warm Gulf Stream might never have reached northern Europe, leaving it a frozen tundra. Had Greater Adria not been subducted, the Mediterranean would be an arid desert, and the history of human civilization would look unrecognizable. These lost worlds are the invisible architects of our present, shaping everything from the air we breathe to the food we can grow. We are only just beginning to understand that the lost parts of our planet are still active participants in its complex living systems. Every new mapping mission brings us closer to a world where the ocean floor is no longer a mystery, but a detailed map of our past. But as we illuminate the dark, we must decide if we are searching for understanding or simply for more things to consume. The story of our planet is a long, slow epic of transformation, where today's seabed was yesterday's mountain, and today's continent is tomorrow's abyss. As we have seen with Doggerland, the ground beneath our feet can disappear not because it sinks, but because the climate simply reclaims its territory. The rising sea levels that swallowed that prehistoric hunter's world are a sobering reminder of how quickly our own modern coastlines could shift. But the deeper mysteries of Zealandia and Greater Adria teach us that the very structure of our world is far more dynamic than we ever imagined. These lost continents are not just historical curiosities, they are massive reservoirs of tectonic energy and geological memory that continue to pulse. Beneath the Indian Ocean, the shards of Mauritius remind us that even the most stable-looking landmass can be ripped apart by the movements of the mantle. These fragments are the debris of a planetary divorce, scattered witnesses to the violent birth of our modern oceans and the drifting of our homes. In the north, the controversy of Icelandia forces us to confront the limitations of our scientific models and the complexities of our legal boundaries. We are discovering that the crust is not a uniform shell, but a patchwork of ancient veterans and young volcanic newcomers overlapping in the dark. This geological complexity is why we still know more about the topography of the Moon than we do about the 71% of Earth covered in water. Every time a marine archaeologist recovers an antler, harpoon, or a mammoth tusk, they are pulling a thread from a much larger, hidden tapestry. We are learning that the Earth does not just have history, it is history, a living, breathing archive of everything that has ever lived and died. The discovery of Antarctica's hidden forests proves that even the coldest places on our planet once basked in the warmth of a different sun. It shows us that the normal we see today, the ice caps, the deserts, the current coastlines, is merely a brief interlude in a multi-billion-year symphony. As we develop the technology to peer through kilometers of ice and water, we are essentially building a time machine for our own planet. But with this power comes a profound responsibility. The responsibility to protect the history we uncover from the hunger of our own industries. Deep-sea mining and Arctic exploration are the new frontiers of human ambition, but they risk erasing the very secrets we are trying to solve. We must ask ourselves if the minerals and fuels hidden in these lost lands are worth the cost of destroying the ecosystems that call them home. The continents are still moving, still changing, and still hiding secrets that could hold the key to our survival in a warming world. Our journey into the past is not just an academic exercise. It is a vital mission to understand the true nature of the planet we call home. We often talk about Earth as a finished world, but we are merely living in one brief frame of a cinematic epic that has been playing for eons. The lost continents of Doggerland, Zealandia, and Greater Adria are not just chapters in a history book, they are the restless foundations of our future. As the North Sea currents continue to shift and the African plate continues its slow northward grind, new geographies are already being written in the dark. Thousands of years from now, our own familiar cities might be the mysterious ruins that future explorers pull from the bottom of an expanded ocean. This realization makes our human concerns feel tiny, yet it highlights the incredible curiosity that allows us to map the invisible and know the unknown. We are the only species on this shifting rock that can look at a piece of deer antler and reconstruct an entire vanished civilization. We have learned that the Earth is a masterpiece of recycling, constantly destroying and reforming itself to maintain a delicate, life-sustaining balance. The freezing current around Antarctica and the warming flow of the Gulf Stream are the invisible hands that decide who survives and who thrives. But as we stand on the edge of the abyss, ready to mine and exploit these sunken worlds, we must remember the lesson of the fossils. Every species that walked the forests of Antarctica or the plains of Doggerland believed their world was permanent, solid, and eternal. We now know better. We know that permanence is an illusion and that change is the only true law of the planet we call home. The discovery of Zealandia and Icelandia suggests that there are many more ghosts waiting to be found in the vast, unmapped stretches of the deep. Perhaps there are entire ecosystems we haven't even dreamed of, thriving in the high-pressure canyons of continents we didn't know existed. Our journey of discovery is just beginning, and the seafloor remains the ultimate frontier, a mirror reflecting our own fragility and our boundless ambition. Will we use our new technologies to become better stewards of the Earth, or will we repeat the mistakes of the past on a global scale? The minerals hidden in the crust could power our civilization, but the knowledge hidden there could save our souls from the arrogance of permanence. As you walk outside today, take a moment to feel the ground beneath your feet and remember that it is a traveler, just like you. It has been to the poles, it has been to the equator, and it may one day return to the fire from which it was born. The continents may be lost, but the story they tell is found in every rock we touch and every mountain we climb. In a universe of shifting stars and drifting worlds, the search for our lost lands is ultimately a search for ourselves.